Hi there, my name's Jackie Decker, and I'm going to share with you a thinking routine called concept circles. We learned about these from Dr. Cathy Marks Krpan. You can also find out about concept circles on page 190 of this book, Teaching Math with Meaning, which also contains a little bit more of the why and some other thinking routines that are helpful in your classroom. Why would we use concept circles? Well, as you'll see as we dig into this thinking routine, the structure of them allows students to discuss their ideas, to really focus on conceptual thinking, which allows them to build a deeper understanding of the math. This allows their brain to make key connections while they are learning different math concepts. So what is a concept circle? It's actually just a structure, and we define something in the center based on a particular topic right in here. And then students create new representations in all these sections around the outside of the concept circle. They might use pictures, numbers, symbols, or words, and that will often include manipulatives and visual models. Many concept circles look like this. A number is defined in the center, and then students are asked to represent that number in many different ways around the concept circle. There may also be instructions on sticky notes placed around the concept circle that students are considering when building those representations. Here are some examples. On the left, we have 1/4 being represented by time, by an area model, by a set model, connecting to measuring cups. On the right, we have a number defined in the middle, and students are asked to think about 4 less, the same amount, 5 less, 2 more. Another example is in outdoor play. We have the number 6 defined in the center, and students are using all sorts of different found materials to represent that number. Another common way concept circles are used are to define the whole in the center, then use sticky notes to indicate the fractional or decimal amounts that you would like students to represent. Here's an example where we are using 2 hexagonal pattern blocks to represent the whole and asking students to represent different fractions around the outside. We see others here where we're looking at decimals and fractions and connecting those to money. On the right, we have defined the 100 flat of our base 10 materials as 1. And now we're thinking about what some decimal amounts might look like and what some fractional amounts might look like. On the left, we've got the 100 flat as 1, but we're connecting that to a loonie so students can see visually and spatially the concept of $1 and the sense that we might find in that dollar and connecting it clearly to their understanding of decimals. A final example is combining decimals, fractions, and percentages to build a better understanding of all three. So what's the teacher doing while students are working together in a concept circle? Because students are in small groups, they are talking to each other about their thinking, they're actively listening to each other, they might be agreeing or disagreeing, and we're listening to see what our students understand, what they understand deeply, what their emerging understandings are, and what their misconceptions might be. We're also listening for math language that might be coming out of these discussions. Concept circles are quite easy to differentiate. We might modify the number of sections. We can have as few as 3 or as many as 8. We might also give different cards or sticky notes for different groups, depending on where they are in their learning, but expecting all students to use the same tool or manipulative. So you might have a concept circle about making 10. You might do it about representing different fractions. Maybe you're thinking about symmetry, angles, area and perimeter, addition and subtraction, multiplication, different types of polygons. In each one, think about what it is that needs to be modeled or defined in the center and what it is you're going to be asking students to represent in many different ways around the outside of the concept circle. So I leave you with this thought. How will you create a concept circle for your students?